Unifying FSD with Optimus is a pretty interesting approach that Tesla seems to be pursuing based on Ashok's recent comments. We want to discuss what that actually means and also what the potential is for, not just for Tesla, but generally for robots. This is not even a podcast. It's October 9, 2025. This is Krimdelko. For the day, we're down roughly 10 basis points. The market is down 20 basis points for the year. We're up 16.4%. The market's up 14.4%. We're outperformed by 2%. Roughly, the markets are still open. These numbers could change. So Ashok recently put on X that they're thinking of combining FSD with Optimus, which is nothing absolutely shocking for, I think, for the community. We've seen already with RTX, the Google project. We've seen it in other areas. Fei-Fei Li's world model approaches are also working in that direction. There seems to be a generalization of real-world training that works for robots. In other words, you can learn how to skate from biking. You can learn how to fold papers from folding towels. There is a certain Platonic representation of intelligence. We've spoken about this also on this podcast series. So all of that together actually makes it almost straightforward that we should expect a unification of FSD with Optimus. In fact, when Musk announced that he wants to do a robot, I don't know how many years ago this was, that was our first thought. Is there transfer learning? Is there a combination between what they're learning on the FSD side with Optimus? Now let's put the lay of the land first. I think FSD 14, V14, and Robotaxi are the first embodiment of autonomous driving as solved problems in the real world, in the wild. And you know, we are actually using it. So there's nothing more powerful than real customers using a product. I think it's beyond the judgment now of experts whether this is working or not. It's working, it's solved. And from an academic perspective, that's a big win, because we have now, we have an approach, we have a way to explain how real-world AI actually might work. And this is what FSD has done. FSD has been trained on real-world driving data. So Tesla has built an internet of driving. Very, very importantly, it has defined what good driving actually means. And with good driving, you can then define goals to pursue good driving behavior while constrained on, let's say, getting from A to B. So once you have a benchmark for what good driving actually means, what good behavior on the road means, you can then learn how to do that at scale. And this is what FSD has done. So having the benchmark itself is already a massive advancement. And I want to go back to CVPR 2024 when I was in Seattle and I spoke with a few people. And I think that came across. That was a big win for us as investors in Tesla, because as we discussed many times in this podcast series, when we deal with these types of situations, it's sometimes frustrating not to be in the actual action, not understanding what people are doing. But when we understand from a scientific perspective where things are going, we have a good sense for where the companies that we investing should be going. And I think that's kind of the way we feel about Tesla now. That's why we're very confident to be investors in Tesla, even though the volatility sometimes can be pretty heart-wrenching. So in this case, I think we understand where the puck is going, to use Wayne Gretzky's comment. And that's really important. So we have the benchmark, and now what does unification mean? I just read Jim Phan's PhD thesis. He did his PhD with Fei-Fei Li in 2021. He's now heading GROT, I think, or something, GROT, which is a foundation model for robots endeavor at NVIDIA. And what this PhD thesis, which has been published 4 years ago, so imagine he's basically started probably about 6-7 years ago to think about these things, and that's like 100 years in AI terms. So, but nevertheless, I think he solved a few fundamental problems in his PhD thesis. For example, efficient learning from video, efficient reinforcement learning. So a lot of things that can be used now whether it's at NVIDIA or Tesla or other companies. So that's what I think it takes to actually get to where a real world deployment of mass robots. It's going to take a lot of the ideas that come from thesis, like for example, Fan's thesis. But one of the more important things that he solved in his thesis was, other than video learning, it was the incorporation of priors into video models. And that what's important about priors is, which is kind of, think of priors like, it's almost like when a baby starts learning to walk and then in school starts learning to write. There are some priors, like humans aren't learning from scratch, and those priors, that's kind of the same idea here. So it's not hard-coded, but it's something that maybe helps the model go into the right direction when it does reinforcement learning. So I think that's where we see the marriage between the idea that Fan promoted in his video, in his PhD thesis, and what Ashok is saying, that we could use the FSD as a prior for Optimus. And then maybe in the future also, of course, Optimus as a prior for FSD. So for example, real collision avoidance can be transferred into walking around in a building and not hitting people, or walking around in the factory and not hitting people, walking around the factory and not damaging things. So a lot of knowledge, prior knowledge, navigation knowledge that is gained from FSD can be used in robotics. So this is just one example of how this combination of FSD and Optimus is a pretty big deal. I think it's one of those things that in the back, in a few years, we will go back. It's kind of like when Musk decided to get rid of LiDAR. It's a small thing maybe, but it's a big deal. And I think this is one of those things. So again, to summarize, when Ashok mentioned FSD and Optimus being combined, we are connecting that with, which just happens to be something we read, the PhD thesis by Jim Fan, but there could be others that I'm not, giving enough credit right now, who have written about this. The idea is, again, to start with some priors, learned priors that can be sort of helping, like a scaffolding, to build up a learning environment that is more efficient and more effective in pursuing goals. The last thing I want to say here is where I disagree with some of the approaches that I hear, particularly from Fei-Fei Li's side, and I could be misunderstanding her and her endeavor in the world model endeavors that company that she has right now. I hear a lot of talk about skills and skills and skills, and I don't think it's about skills. I think it's about pursuing goals. So I'm a very, I'm a Richard Sutton, fan, for lack of a better word. I'm bitter lesson pilled when it comes to that. So it's about pursuing goals. It's not about understanding how to fold anything. It's about cleaning the apartment. It's about cleaning the hotel room. It's about cleaning the factory floor. That's the goal. And how do you actually achieve it? The robot learns that, and whether he needs to understand how to fold towels, that might be the case. But that's kind of a subordinated task that is subordinated to the goal. The goal is what really matters. So for example, the goal of a robot is, again, you train to clean the apartment, you train to keep something clean. The higher abstraction, the more general the goal is, the better the robot can learn, and the more intelligence it can actually exhibit. So that would be one thing where it's not really a critique. It's just our approach towards the way we see it, and I think that's also how Musk is, because that is what end-to-end learning actually means, and I think that is where Tesla is moving towards. I think the other thing I want to say, which is certainly not earth-shattering, I'm sure anybody who follows AI will agree with me, but it is definitely that time compute, which is the combination of compute and memory, so availability of data while compute is being done, like that is by far the most important driving factor in developing intelligence, no matter how you slice it and dice it, because whether it's long context windows, whether it's more complex environments, whether it's accelerated reinforcement learning, I think compute is gonna eat strategy and smart models for lunch, just to use the analogy. To summarize again, the combination of FSD and Optimus is a big deal. It's in line with, for example, Jim Phan's idea of putting priors, learned priors into robotics models. And when everything is said and done, the real important thing is that we have more and more compute available, more compute time available, because that way we can run more scenarios, and iteration and scenarios is in the end what intelligence actually is all about. Thank you.